Good day to you. This is teacher Leland, Alejandro, and we're going to discuss symmetry as part of our Algebra 2 lessons. So in symmetry, we're going to discuss something about line symmetry and rotational symmetry. These are so related with um, even functions and add functions respectively. So let us try learning this through examples, and we're going to use the Desmos graphic calculator. All right, so let's see the screen for this. Okay, here's the Desmos graphics calculator, and we shall try to put some equations, and we're going to identify if these are odd and even functions and what type of symmetry this graph displays. All right, we will start with line symmetry. All right, I'll show you a graph of an equation which shows symmetry with respect to the y-axis. So this is called the line symmetry. This is the absolute function, okay? And you can see the graph of this. It has a set of points in the first quadrant and corresponding reflection at the second quadrant there, which makes the y-axis the mirror line, which is the line of symmetry. So this particular function, the absolute function equation that you see here, demonstrates a line symmetry. And this is considered even function. Even functions. Now, an even function, most even function, or all of even functions are symmetric with respect to the y-axis. All right, so I'll give you another example. Let's erase this first. Let's consider a parabola, all right? Y is equal to 0.3x squared, there. Now this is a parabola, right? A quadratic function, and clearly you can see the set of points at the first quadrant has equivalent set of points at the second. And again, the mirror line is the vertical y-axis there. And this is considered even function. You can see the exponent 2. Okay. One thing about even functions, the exponents of the variables are even. Okay. That's one thing about even functions. Okay. We can also show a graph, a trigonometric function graph, which is symmetric with respect to the y-axis. And this graph is the cosine. All right. So this is quadratic equation, quadratic function. Let's consider the cosine that I'm talking about. Y is equal to cosine x. There. Okay. For every point on one side of the y-axis, there's a corresponding set of points at the left side of the y-axis. So this cosine graph is symmetric with respect to the y-axis. You can see the vertical y-axis, and any set of points at the right has a corresponding set of points at the left side of the y-axis. And this is said to be symmetric with the y-axis. Again, this is line symmetry. Okay, line symmetry. All right. Now, all even functions are line symmetric with the y-axis. And how can we tell if the function is an even function? One thing about it, the exponent of the variables are always even. Okay. So even number means starts with 0, 2, 4, 6, 8, 10, 12, etc., etc. All right, those are the even numbers. So I can give several examples that will be line example of line symmetry. Okay, and The line of symmetry is the y-axis. All right, here's another. X raised to 2 plus x raised to 4. There. You can see the exponents of the x variable is 2, that's an even, 4, that's an even. If we place any number there, that is considered 0 degree. So for example, I will add, say, just any number, say 1. This is considered x to the 0. That is 1 times x to the 0. Okay, like that. So this is x to the 0. So it will not change the graph. It will still be symmetric with the y-axis. So if you have a number, that is considered x to the 0, and that's considered even function. So 0, 2, 4, 6, if we add some more here, say we have minus x raised to 6 there, that will still be symmetric with the y-axis. Okay, the right side of the y-axis graph has an equivalent exactly identical with the right at the left side there. So this is what we mean by even function, and this produces a line of symmetry using the y-axis. Okay, so you can vary the graph, okay, by putting some coefficients there, and the coefficients won't change the symmetry. Okay, if you place here 5, okay, if you place here 0.1, that won't change the graph. Okay, so if you make this point 5, or put here 0.7, okay, it will not change the graph. Okay, even if you put their numerical coefficients. What matters here are the exponents. If the exponents are even numbers, it will produce a line of symmetry with a y-axis. Okay, all right, so we have used 2, 4, 0, and 6. Those are even numbers. Now, x to the 0 is not usually written. Okay, so we can actually erase this part like that. There, and it won't change the graph at all. Okay, so remember, any real number is supposed to be a numerical coefficient of x to the 0, or variable raised to 0 exponent. Okay, so that's considered even, 0, 2, 4, 6. All right. All right, so it's easy to understand line of symmetry, or symmetric with the y-axis, and these are the even functions. Now we can consider a different picture, all right, of the equation. If you want the variables at the denominator and the exponent of those variables are even, that can still be considered even function. Okay, for example, I will make this 1 over x squared there. Here's the graph, and you see it is symmetric with the y-axis. This is still considered even function, and it produces a line of symmetry with the y-axis. Okay, and notice again the exponent is 2. That's an even. If you make that 6, okay, that will still be line symmetry. Okay, there, and the mirror line y-axis is the line of symmetry, and you can always tell if it's symmetric with the y-axis. All points at the right side of the y-axis has an equivalent at the left side there. Okay, so no matter what number you place there, it will not change the picture, even if you put some numbers on top, say 10 there, or higher number, 25, you will still have the same picture. Okay, and even if you add another, say plus 1 over x squared, like that. So that's another even number there. All right. So this is how you see line of symmetry using the y-axis. Okay, so this is line symmetry. Now later we're going to study the rotational symmetry. Okay, so that's it for the even functions. Even functions have the variables using even numbers, starting with 0, of course. Okay, all right, so that's it. Now you might want to try other even number. You can use 1 over x to the 4th, like that. Still, it will not change the picture. Okay, there. So there are points at the right, and all of those points has an equivalent at the left side of the y-axis. All right, so these are the even functions. All right, so this will produce line symmetry. All right, let's have the rotational symmetry, which is actually the add functions. All right. Add functions, of course, as the name implies, the exponent of the variable x will be odd numbers. So what are odd numbers? 1, 3, 5, 7, 9, 11, etc., etc. So if you try to put a number on top of the x as exponent, just make sure it is odd to make it an odd function. And then the nature of odd function, all points in one quadrant, okay, will have a counterpart at the opposite quadrant. Okay, so let's show that. Okay, this is 1. Okay, this is an odd function. All points you see at the first quadrant will have corresponding points on the opposite quadrant. Okay, at the third. And this is what we call symmetric with the origin. Okay, point of origin 0, 0. So there is a 1, 1 here. Okay, there's a 1, 1 point here. And there's a negative 1, negative 1 on the other side. Okay, so to demonstrate the nature of rotational symmetry, okay, if you rotate this, it will go back to the same picture. Okay, if you rotate this, all right, this will actually show the same appearance. So if we consider a point 1, 1 there, there's another point equivalent to this, opposite, okay, to the third quadrant, okay? That is negative 1, negative 1 there, okay? Another point 2, 2. There's a corresponding point, the opposite quadrant, negative 2, negative 2, okay? And we can show that, so negative 2 and negative 2 there, okay? So if you're talking about symmetry here, they are symmetric with a point of origin 0, 0. You can see these points having its midpoint at 0, 0, all of this, okay? So this is one equation, y equals x, all right, which displays rotational symmetry, okay? All right, let me change the graph, okay? All right, let's consider exponent 3. 3 is an odd number. Y is equal to x raised to the power 3. That's an odd number, and you can check it out. Try to see the graph, okay? Try to see the graph. All points at the first quadrant has equivalent points at the third quadrant, okay? The opposite quadrant, the other side, okay? So all you see here is corresponding right down there, okay? So 1, 1 is over here. So let's consider some points, okay? So 1, 1 there. And on the third quadrant, we have the negative 1, negative 1 there, okay? The red point you can see, all right? And so you can just use your pointer over here. You can just use your pointer here. All right, there. There's a point there that has a corresponding point over here. And these 2 points here, this point here, and this point over here, symmetric with the origin 0, 0. Okay. Also, this point here and this point here, symmetric with the origin, point of origin 0, 0. That's a 0, 0. Okay. Similarly, if you consider a point up here, there, that is 1.43. That is also over here, negative version there. Okay. All right. So this is what you call rotational symmetry. And notice the exponent of the x variable are odd numbers. So this is called odd function. Okay. And you can vary the exponents as long as you use odd numbers. So if we add, say, x to the fifth, right? If you put there x to the fifth, all right, it will not change the picture. Okay. You can put some coefficients there, 0.01 over there, or over here, 0.03. All right, it will not change the picture. All points in the first quadrant will have corresponding points at the third. Okay, like that. All right, this is considered add function. Add function. All right. So 3 and 5 are odd numbers. Okay. All right. So there's another type of equation, trigonometric. This is the sine function. This is considered odd. There, that's an odd. For every point, all right, at the right side, we'll have a corresponding at the left side. But these partners are symmetric with the origin. Consider the tip here, okay? The corresponding point for this one, okay, using rotational symmetry is over here, it's down here, okay? They are symmetric with the point of origin. So this point and this point is a pair, okay? Another is a point right here, all right? Look at the pointer and the point over there. Again, the midpoint of these 2 points is the point of origin. If you consider this point down here at the fourth quadrant, the opposite point to this one is the maximum point over here, the second there. And again, the midpoint of this and this is the point of origin. So this is considered symmetric with the origin. Okay, so this is add function. So our conclusion, cosine function is symmetric with the y, while sine function is symmetric with the origin. Or in other words, cosine function is considered even function, while the sine function is considered odd function. Okay, there. So this is the add function. All right. So in general, if you try to make use of the variables, say variable x, you just have to use odd numbers. X, x cubed, there. X to the 5, there. Okay. So you see the set of points will have a symmetry with respect to the origin. So if you're going to investigate this graph, the point at the first quadrant, okay, the pair for this is the point at the third there. And the midpoint of these two is the origin. Consider this point at the right side of the axis. The counterpart for this point is the other point at the opposite, okay, opposite direction. And the midpoint of these two is the origin, all right, there. This is how to analyze this add function graphs. So consider this point here, okay? The other point corresponding to this is at the second quadrant. It's over here, there. All right, there. So this is how to check add functions. So if you put on more x variable there, just make sure it's add number as exponent there. regardless of the sign here. If it's minus, if it's plus, okay, there. You can even put there some numbers. There. It won't change the picture, and it won't change the rotational symmetry. It is symmetric with the origin. So if you use odd numbers as exponents of the variable x, you will have the rotational symmetry. Okay, rotational symmetry. It is called rotational symmetry because if you rotate this, it will go back to the same appearance. Okay, it will go back to the same appearance. Rotating it at about 180 degrees, it will go back to the same appearance. Okay, all right, there. So this is the nature of add function. Now, how about a combination of odd and even? That is now what you call neither odd nor even. Okay, so it will not have any symmetry. Okay, it will not have any symmetry. So, for example, let's use a combination 1, 2, 3, 4, 5. Okay, y is equal to x plus x squared plus x cubed. There, all right, and then plus x to the fourth. There. So you see, there is no more symmetry here. It's not symmetric with the y-axis, and it's also not symmetric with the origin. Okay, if you use combination. All right, so there you can see the graph, the appearance of the graph. All right, so it's either odd, even, neither. All right, there. Okay, so that will be all for our line symmetry and rotational symmetry lesson. Okay, so I hope you were able to learn from the given examples that we have for this discussion. And thank you, and see you later. Bye bye.